In this video, we'll introduce the concept of solving systems of linear equations using elimination. So if you haven't already, I definitely recommend checking out the intro to systems of equations, as well as the videos on substitution, as those are very helpful for understanding this next concept. So elimination, I think the best way to do it is to kind of look at an example. So let's say we wanted to solve this system that's up here. We have 2x plus 2y equals 12 and negative 2x minus a y equals 9. So what we could do if we wanted to try and do substitution at this point is we could try and manipulate one of these two equations to where eventually we have either an x equals something or a y equals something. And then we could substitute that in for either x or y, whichever one we substituted for. We could do that, but it turns out there is another way, and I'm not prepared to say it's better in this video. It's a different way, and sometimes it can be better. So between substitution and elimination, there are some instances where one is easier to use than the other. So here's the core idea of elimination. So if I look at this top equation, I know that both of these things I've underlined in red are equal. And we know that we can add and subtract equal things from two different sides of an equation. So the idea with elimination, and this example is kind of a simpler one to kind of iterate the point, is that technically I can add the two expressions on the left and the two numbers on the right, because then I'm technically adding the same thing to both sides of the equation. They're both equal to 9 if I consider the blue equation adding it to the red. Both of these two expressions here are equal to 9. Both the red expressions are equal to 12. I'm essentially adding 9 or 12 to both sides of an equation depending on how you're looking at it. Now this is beneficial because if I look right here, 2x plus a negative 2x, which would be the same as 2x minus 2x, it's going to be 0x. And this is why they call it elimination. You're eliminating a variable, in this case an x. And now I'm going to carry through with the rest. So the next thing I'm going to look at right here, 2y plus a negative y, or 2y minus a y, which is just going to be a positive 1y. And then we will look at our numbers. 9 plus 12 equals 21. So this one worked out pretty nice. It's telling me, hey, y is 21. Now at this point, just like we did for substitution, once we have one variable in, we can plug it back in to solve for the other. And we get to kind of pick which one we would like to plug it into. All things equal, let's pick the one that'll be easier. I'm thinking the second equation to solve for x. That way I don't have to double the y. So we're going to look at negative 2x minus 21, because that's what y is equal to 9. At this point we can solve this equation for x, and then we can be done with this example. So let's take a look, see what we can do. Let's add 21 to both sides. So 2y, or 2x I should write, is going to be equal to, looks to be 30. So this would mean that x is going to equal negative 15. And that would be the solution to my system. And since we are dealing with x and y's, we could also give our solution in terms of a coordinate pair. So negative 15, 21 would also be an acceptable way to write this solution. So elimination at its core is a somewhat simple idea. The idea is I'm going to eventually add or subtract conveniently to eliminate one of my two variables. In this case we eliminated x, but you can also eliminate y. And we'll talk about some more complex examples and how we can kind of stretch this idea in future videos. For now we'll do one more example where it's fairly simple, and then I'll have another part where we look at something a little more complicated. So let's look at another example here. Let's say I have 3x plus 2y equals 12 and 4x plus 2y equals 8. Now, if I'm looking at this and I'm trying to think, okay, how can I eliminate one of my variables? Well, I can't add, because if I add here, if I'm looking at the y's, they are the same. And that's a good thing, because then I can potentially eliminate, but I don't think I can do so with addition. I think we can with subtraction, though. If I take 2y minus a 2y, that would make my 0y. And that's how I decide whether I'm going to add or subtract. I'm going to look and try and figure out, okay, how can I make this happen to where I will get rid of one of my variables. Okay, so our next step would be to carry through with the rest. So I'm going to look at the x's. 3x minus 4x is going to be a negative 1x. And we got to be very, very careful with our signs and our coefficients here. Be very careful with the arithmetic. And then we're going to look at our constants over here on the right side of the equations. So we'll look at 12 minus 8, which is going to be 4. So this is going to tell me that negative x is going to equal 4, which means that positive x is equal to negative 4. I'm halfway there. So then I can plug this back in. Looks like it'll be about the same either way we go. I'll just go ahead and plug it into the top equation. So we'll have 3 times negative 4 plus 2y is equal to 12. Guess I don't know why I needed that extra parenthesis, but we'll just do that really quick. So if we're solving this, we'll have negative 12 plus 2y is equal to positive 12. We'll add 12 to both sides, so 2y will equal 24. And then y will also equal 12. And we can make that deduction. And again, we could give our solution in terms of an ordered pair, but we don't have to in this case. So there's elimination if we're just looking at addition, subtraction in the cases where it's convenient, where either the coefficients of one variable are indeed the same, or if they are same but opposite in sign, really convenient to just add or subtract. Now, a quick note with elimination. If I had something as, say, y equals 5x plus 2, and I tried to do elimination with 2x plus 3y equals 7, I have to make sure that they're of same format. Otherwise, I'm going to be causing it won't be as convenient, I guess. It'll be causing some problems. And what I mean by format is if we look at these, both of these are in what we call standard form. ax plus by equals c. And the idea is that both equations are of that format. So either I need to just have them in a consistent format. So the idea is basically you have your x's, then y's, then an equal sign, then c, or you could rearrange it to where maybe even both of them are in slope-intercept form. And then you could do elimination very easily there too. So you've got options on how you do it, but just make sure that they're consistent in their kind of layout of the equation.